All right, so we're going to be looking at the five methods of apportionment that the U.S. has brought up, and the main big ones that have been used, the ones that have been used in America, and the one that was actually created and brought up by a president, not while he was in office, but one that was discussing. So the first thing we're going to do is we're going to talk about the first ones that came up. So the first two that came up was the Hamilton's method, made by Alexander Hamilton, and Jefferson's method by Thomas Jefferson, our third president. And so Hamilton's method, as you know, what it does is it takes, once you have your standard divisor and you divide everything through, you take all the numbers, so let's say it's 31.24, and what you're going to do is you're always going to take their lower quota. You're going to round them all down. Okay? And when you round them down, what you're going to look at is you're going to be looking at what's called the residue, which is the decimal part, the point, whatever, or after the decimal point, everything right to the decimal point. The states with the largest residues will get the extra seats. Okay. Now this method was used from 1850 to 1900. It wasn't used early on because Jefferson's method was used when Hamilton actually originally brought this up. But later on in 1850, it was brought. It was like, well, this seems pretty fair. It seems like it's going to work out, and it was used for 50 years, whenever the census is. The one good thing about this is that it does not violate the quota rules. It doesn't break a upper or lower quota violations. It doesn't break those. The problem is that it does favor the larger states, not too much, but it does favor them, and in some cases, in most cases. But the three paradoxes that we talked about, the Alabama paradox, the new state paradox, and the population paradox, Hamilton's method is the only one that violates all three of those. And so that was the big problem with Hamilton's, and that's why around 1900 they stopped using it, because they kept running into these paradoxes, and Congress was just getting sick and tired of this, and having states, try to basically go to the Supreme Court saying, hey, they took one of our seats that we rightly deserve. And so that's why Hamilton's method isn't used anymore. But Hamilton's method looks at the residue. Largest residue gets the extra seats. Jefferson's method. Now, Jefferson's method was used in the early part of America. It favors the larger states a lot. Very much it favors the larger state. It doesn't have any paradoxes, but it does break the upper quota rule. And it does violate that. And the reason for that is because with Jefferson's method, you're going to use something called a modified divisor. So we have our standard divisor, which is a number that's set, like in Hamilton's, we have our standard divisor. This is what it's at. Well, Jefferson's, once we do that, the first time you see, okay, we have to adjust it in some way, we're going to move that divisor around. Okay? And usually what happens is, with Jefferson's method, you take the lower quota, okay? You take everybody's lower quota, and then you just keep doing that. And what happens is that when you take your modified divisor is actually going to become a smaller number as well. So you're going to take a smaller number for the Jefferson's method for your modified divisor, and you're always going to take the lower quota. And then when everybody works out and you add them all up and you get the total you need, that's when you're done. So there's a range of modified divisors that would work in Jefferson's method. But again, it violates the upper quota rule. And Jefferson's method uses the lower quota. Now, around 1832, there's a bunch of hoo-ha about stuff that was going on, and a lot of Congress was getting upset with different things and wanted all this to stop. And basically what ended up happening was two more men brought up their own methods. One was John Quincy Adams, okay, another president of the United States, in 1832. And basically what his is the opposite of Jefferson's method. So instead of taking the lower quotas, he always takes the upper quotas. Okay? So he always takes the upper quota, which means your modified divisor will always be larger than the standard divisor. And you keep making a modified divisor that's bigger. Okay? His method was never used because everybody was like, well, it's just like Jefferson's, and we want to move away from Jefferson's. So why would we just do the opposite of Jefferson's? Why? It's the same thing. Now, Adams' method does break. It violates the quota rule, but it only violates the lower quota. Okay, so a state will get less than its lower quota. Doesn't have any paradoxes, and it favors the smaller states. So the smaller states would want to use Adams' method, but the larger states would not, because the larger states would be the ones that violated that lower quota rule. Never used in the U.S., but it was one that was discussed. After that, Webster, same time in 1832, Webster brought up his own method of doing it, and this one seems like it's pretty good. It is very neutral. It doesn't favor either states. It doesn't have any paradoxes. And basically, what his method is that you look at the arithmetic mean of the upper and lower quota, which is 0.5, and you just do basically rounding. If it's higher than 0.5, you round up. If it's lower than 0.5, you round down. Okay, pretty straightforward, pretty easy. The problem with this one is that your modified divisor will be both above or it could be below, depending on the situation. And it violates the quota. It can violate the quota rule, both the upper and the lower. So it can violate both those, which is a problem with it. But this one was only used. It seems like the one that would be the most sense, but it was only used 4 times in the U.S. In 1842, after the whole thing in 1832 with Jefferson's Method freaking everybody out. It was used the next census, and then after that they jumped into Hamilton's. And then after Hamilton's method kept getting the paradoxes, they went back to Webster's. And as you see, in 1920 there wasn't any, and the reason is because Congress decided they didn't want to do one, which was against the Constitution. But anyway, they just decided they didn't want to do an apportionment that year. And so that's why nobody did it that year. Now, after 1831, what ended up happening was in 1920, Congress was getting very upset with states, going to the Supreme Court saying, "Hey, these seats are being taken away from us. We want this to stop." So in 1929, Congress commissioned basically the Math and Science group and said, "Okay, we need you to come up with a method that will work always, always, always. The best method for apportionment that you can create, and we want to know what it is." And so basically what they did was they took a couple years, and then finally in 1941 an act came up into Congress, and this act was called an act to provide for apportioning representatives and Congress among several states by the equal proportions method, or in shorthand the 1941 Apportionment Act. Now this act had three big things coming in it. Number one was that it was permanent. It wasn't going to change. This act was here until the end of time. They're always going to use this method. The second one was it's self-executing. Congress wouldn't have to vote on it every 10 years to make sure it worked. It would always, every 10 years, it just keeps doing it. And the last one was that it sets the seats at 435. So that's how many seats in Congress there were. Previously, Congress would move around the number. Sometimes it'd increase by like 3. Other times it wouldn't increase. And so what they did was it set at 435. And the only time that changes is if more states are added to the Union. When more states are added to the Union, that number will increase, but otherwise it stays at 435. Now the method that was brought up for this was the Huntington method. Now, the Huntington method focuses on the geometric mean. Now, Webster's method deals with the arithmetic mean. Huntington deals with the geometric mean. So you still have your modified divisor and everything's the same, but instead of going at 0.5, they use the square root of the lower quota times the upper quota. And basically what happens is, like, if you have 32 times 33, that number comes up to be about, the square root of those two comes up to be about 32.496. So if your number is higher than this, you're going to round up. If it's lower, it goes down. And so that's the Huntington method. That's what's still used in the U.S. today.